there have been many new developments, I believe, which are extremely important and which will have great implications in future. To name a few, I would like to quote two things. One is cloud computing, and the other is mobile access. Just two examples to quote the importance of the shape of things to come in future. I believe cloud computing and mobile access are complementary to each other now, particularly with the development. You know that the penetration of cellular phones has increased phenomenally in society. And with this penetration, the number of people and the number of devices that are accessing the net is increasing, an increasing phenomenon. And therefore, once this traffic which is accessing the net increases, this spike in demand requires handling capabilities to process data which are terabytes, petabytes, and even more. The computational techniques of future will require evolution of techniques which would be capable of handling such a voluminous, phenomenologically voluminous, I would say, data, which would be unprecedented with great skill, intelligence, and particularly for those people who have no background or very little background to statistics, for example, in algorithms. A lot of people like me, for example, use internet. For example, the mobile system now, you see, have integrated everything into themselves. They have replaced television, they are replacing computer, they are replacing music systems, they are replacing communication devices. And therefore, developing capabilities which will handle very large amount of data for those people who have no knowledge or very little knowledge of statistics or algorithms, how to handle, how to develop such computational technique is going to be a critical challenge in future. There will be new kind of languages, I suppose, that would be likely to be developed in future. For example, you see access to websites, for example, the attributes, the behavior of any website today is decided by a multitude of characteristics. For example, application code, web server configuration, edge caching server, data grid servers, offline, asynchronous processing, machine learning elements, active network devices, and so on. All these, you see, any website will access to all these things simultaneously. And therefore, and all these may not be using the same, language or same kind of architecture. And so, developing languages which will provide you seamless integration of all these different platforms would be an extremely important development in future. With the development of communication technologies like 3G, we already have 3G and 4G, but maybe when we have 5G and beyond, there will be time when the difference between the physical world and the virtual world would probably not exist with the development in communication technology. We will have great reliance on sensors which will be part of the communication devices, which will not only be transmitting video information, audio information, text information, they will also be transmitting, for example, environment. so that when you talk with somebody who is sitting in Siberia, you can feel the environment of Siberia at Bhopal. So this kind of communication technology would, would eventually, you see, uh, force the difference between the real and the virtual world. So what kind of computational techniques will have to be developed to ensure that all this information inputs are processed very efficiently and rapidly? There is another important development which I believe would be coming very soon and which will have great implication, and that happens to be the development of languages which will rely more on quantum superposition and quantum coherence. Mind you that these two aspects would be, I believe, entirely different from what we have today in our language processing algorithms. You know that all our, you see, software approaches today, even the hardware, they are heavily based on the binary logic. But then eventually, with the development of nanocomputing, for example, which is definitely happening in maybe 20 years from now, we have to completely dispense with the existing software approaches and develop new approaches. So the future is extremely interesting, challenging, I suppose, and the organization of this national seminar, I suppose, will focus on some of these aspects during the academic deliberation. I would also like to take this opportunity to emphasize that we have to also think as to how to, you see, revise, modify our academic curriculum of undergraduate and postgraduate teaching in the light of these developments. I know that most of our engineering syllabi do have very little component, for example, of information theory. I don't know which computer software skill can really be developed without a good knowledge of information theory. Similarly, we have to devise methods of teaching discrete mathematics. I think this is another area which has been grossly neglected. Teaching discrete mathematics is extremely important, particularly for designing very high-speed computing devices which will be using extremely small logic gates, having a voluminous number of such logic gates. So how to design these devices, how to design interconnects so that information processing, data transfer can occur with great speed and reliability. So all these are extremely challenging. I hope you will all enjoy this conference. I wish this seminar a great success, and I would also like to convey my gratitude to the organizers for giving me this opportunity to be part of this seminar. Thank you very much.
Thank you very much, sir, for sharing such motivational words with us.